Hello everyone, my name is Dominic Ranelli, Vendor Relations Manager of T Equipment. Welcome from Casa Ranelli. I hope everyone is staying safe and healthy during this coronavirus pandemic. Joining us today is Jim Miller, who's here to present a great webinar for you to discuss EXFO's magic bullets for optical testing. Thank you, Jim, for taking the time today. We really appreciate you having us. Before I turn the presentation over to Jim, and in case we're waiting for any late joiners to the webinar, I have a couple slides about our company to show you. T Equipment, our company, we have been in business since 2002, approximately 20 years, and we've become a very large stocking distributor. We really do take to heart the slogan, buy from people, not just the internet, and we really have a qualified sales staff here to assist you and help you in any purchases that you may be looking for. As you can see from the slide, we are a national and international distributor. We cover the needs of a wide variety of customer types listed on the left side, and the right side gives you some of the product and instrument types that we do carry. In total, we have approximately $500,000 or 500,000 products available on T Equipment. T Equipment has invested heavily in making the website a great resource for customers and return customers. On this slide here on the left, you can see the filtering capability by specifications to help narrow your search faster when looking for product. On the right side is a screenshot of an internal portal that we have created for a better customer service experience. We're constantly enhancing and evolving T Equipment, our website, and our internal ordering system to help provide a better experience to our customers and end users. All right, so it's now time to turn the presentation over to Jim Miller from EXFO. Jim has over 15 years of experience in the fiber field, over 10 with EXFO itself. And with that, thank you, Jim, for joining us.
Okay, thank you, Dominic. Let me see how I can put my screen up.
I think there we go.
There we go. Show screen. Let me see. Show my screen. There we are. Hold on one second, and let's go to the presentation. And click full slide. And we should be ready to go. Let me get a laser pointer up there, just in case. So thanks everybody for attending. And the topic for today is, although we call them EXFO's magic bullets, I'm going to go into some detail on EXFO's second generation OTDR software, which is called iOLM, Intelligent Optical Link Mapper. And from that, we're going to dovetail into EXFO's newest innovation, which is the Optical Explorer, which is a very nice segue from full OTDR down to something that is a little bit more specific for not as many needs in the field. All right, there we go. So the agenda, we're going to do some brief but very important OTDR fundamentals. I'm going to assume that there's going to be at least a minimal level of usage with an OTDR, but there are some things from how an OTDR works and what it does that is important to understand to really capture the full effect of the benefits of iOLM. Then we're going to talk about how those fundamentals tie into iOLM software. And from there, we'll head into a review of EXFO's new Optical Explorer. And I believe we will have some time for a live demo, which I do have set up here in my office as well. So first, some basics on OTDRs. Now, this is a rhetorical question, but it's an important one. What is the easiest way to shoot an OTDR trace? And without going into a lot of hoopla, the answer is Autotest. And every OTDR has this function to it, which makes really what it says do what it says, which is you hit the button and it automatically tests that trace. Is it the best way to test? There's typically two ways on an OTDR to go about that, not only Autotest, but advanced settings. And we're going to talk about that a little bit. But first, just some things to keep in mind about Autotest. My own personal research from field and seminars is that you really can't just simply attach an OTDR to a fiber span and hit the Autotest button and expect miracles. OTDRs in general, although very capable, are not smart enough on their own to make the decisions on setup and adjustments themselves. They can easily be fooled based on the length of the span, number of events, etc. So what we'll do now is we'll dive into one of the most important fundamentals of an OTDR, which is pulse width. So let's first understand that when an OTDR is shot, it's basically being used like, let's use sonar as an example, radar as an example, even as simple as Marco Polo. It's basically sending out pulses of light, looking for reflectance or bounce back, and then recording that information as those results come in. The actual definition for a pulse width is that it's a dynamic setting on an OTDR that injects a precisely timed pulse of light into the span. In other words, it's flipping a switch on the laser on and off in very, very, very short order. With the illustration on the right, we can see that a short pulse width, which is the width or the length of that pulse of light in the span of fiber, if it is turned on for 5 nanoseconds, has a length in the span of about half a meter. And again, keep in mind that this pulse of light is traveling at the speed of light. And understand that as the longer that time pulse is on or that switch is flipped on, the longer the width of that pulse is going to be in the span. So if we go up to 1,000 nanosecond pulse width, it can be up to or will be as long as 100 meters in that span. And just picture any portion of a fiber span where there may be cross connects or multiple events within 100 meters. It's very easy to see how that pulse of light can cross over multiple events at the same time. And if you bump that up to 10,000 nanoseconds or a microsecond, which is going to be in that fiber at 1,000 meters of length, you can see it's very easy to cover over more than one event at a time. And if it does, then the diode detector in the OTDR is blinded to each individual and only sees merged group events, which makes troubleshooting and full characterization very, very difficult. So keep in mind also, the longer the time pulse, the more power to go further into that span. And one last thing which is important to realize is that this pulse width is being shot down the span hundreds of times a second, if not thousands of times. And each one of those data points or pulses of light creates data points along that span that as you add more and more to them, it then becomes a more refined, more clear image of a trace. Now, this is a very rudimentary drawing, but I think for a basic principle, it fits perfectly. In the upper right-hand corner, you can see that we have basically a span that we're shooting with an OTDR trace beneath it. And if you take a look at the red line, which is the trace for a longer pulse width, you'll see that as it crosses over two connectors with a pulse width that is longer than the distance between those two connectors, it can very easily shade that second connector and not provide individual information. Whereas under the black one with a shorter pulse width, you can see that it can come along and show two distinctly different events that are close together. This is very important in understanding how the pulse width setting can affect the results from an OTDR. Now, there's two types of testing that can be done in an OTDR. We have both auto test and advanced settings. Now, the difference between those two, and this is really as deep as we're going to get today, but the difference between these two is going to show how we can relate them to the second generation software of iOLM, Intelligent Optical Link Mapper. So in an auto test, when you hit that auto test button hooked up to a span, the first thing that OTDR is going to do is determine the length of the span. It's going to shoot out pulse widths until it determines the length and comes back with that result. And then it will set the distance setting based on the distance that it found. So it's fairly straightforward from that perspective. And then based on the length, the OTDR, hold on one second. I think I hit something bad here. Forgive me, I thought I hit something that, there we are. So based on the length, the OTDR picks one of these pulse width settings that you see in the center there and shoots the trace. And what you need to understand is that in Autotest, any pulse width setting is going to be a singular compromise. It's not going to be the best for every event that's on that span, which means you may or may not see every event that is in that span, and obviously that's why you're shooting that trace. You want to see what's in that fiber span. Now, as with advanced settings, the user uses the Autotest first to determine the length of the span and then enters that into the distance. He sets the distance based on that length that he got, and then the user has the ability to pick a singular or multiple pulse width settings to clearly see all events in that span. But keep in mind, under the advanced setting, when he changes that pulse width and does a trace, he then has a complete result for that pulse width setting. If he changes it to a different result, he then has another complete set of results based on that pulse width. So in essence, to fully characterize using the advanced settings, if you have the experience to set it properly, it's going to require multiple traces to be shot and then analyzed and interpreted for what those events are and what they mean in that span. So obviously this is going to require more time and obviously more experience to understand how to massage and tweak those adjustments. So what does this all mean? The very simple essence is that short pulse width of light going down that span will have better resolution, and you'll be able to see more clearly closely spaced events. But what you can't see are going to be events at the far end of long spans because it's not going to have enough power to reach the far end, because the shorter the pulse width, the less power. The longer the pulse width, the greater power. And you cannot see closely spaced events because it will ride over two of them together. And then lastly, you can see events at the far end of the long span, which is obviously why you would dial up that power and inject a longer pulse width into that span. So what does this all mean to me or to you as a tech or someone using an OTDR? And very simply, it means that you've got two choices to make. Autotest may be simple, but it's not necessarily going to be as accurate as you want it to be. Or you can select the advanced settings, which may be accurate, but it's certainly not going to be simple, and it's going to require additional time and experience to get there and make it do what you need to. And how does EXFO address this dilemma? And we have addressed it by introducing almost 10 years ago our second generation software, which is called iOLM, which stands for Intelligent Optical Link Mapper or mapping. And really what it can do is it can make any tech a fiber testing expert. And we'll get into that just a little bit. So as we showed earlier, which one would you choose if you had a traditional OTDR? Again, my research shows most everybody, unless they're truly experienced and been in the field for a long time, they're going to hit Autotest. And also understand that we've got a lot of transitionary workers coming into fiber from, say, the copper world, as well as techs coming into the fiber world that have had no experience in either copper or fiber. So they're not going to have the experience for the for the advanced. So they're going to pick Autotest. And if you pick Autotest, let's take a look at just a standard result of a traditional OTDR. This is typically what you would see from an OTDR graph. It's going to give you the trace, and below that, it's going to give you the event table. And if you just take a first blush at this without knowing what you're looking at, you're going to see a bunch of lines. You're going to see a lot of events. And in the event table, you are going to see, at least in this image, that at event number 2, there's some sort of issue because it's in red. And until you gain that experience, it's difficult to understand and interpret these results as to not only what the issue is, but how do you go about fixing it. So that's traditional OTDR. And I want to compare that with iOLM results, where we've added in multiple features. And the first is we've simplified the GUI and the results that come out of it. We don't provide, although we give you the option for a trace, we don't provide it for the first result that comes out. We provide a linear view with icons. So if I take a look at this result And it's not the same trace. It's just an example to show you how easy it is for the learning curve of learning how to use iOLM. In the upper right-hand corner, we can see what the length of this span is. And here's a linear map of the whole span. In the middle third portion here, global pass-fail, we see it does fail. If we follow the traditional international standards of green is good and red is bad, we can see that at 1668, there is a bad event, and that icon is for a connector. And if we look down below in the lower half of this, we can see the information since there is a square around that event, and everything we have is touchscreen. So by touching that, puts the box around there. It's a connector at 1668, shot at 1625 wavelength, and both the loss and reflectance are out of specs or tolerance because they're both in red. So we know where the issue is, what the issue is, and we also at the bottom, which is unique to iOLM, is we offer suggestions. Again, they may be rudimentary in their design, but for the level of technician experience that we typically see, these can be oftentimes more helpful than not. And there it says the connector or bulkhead's damaged, dirty, or not well connected. So you can inspect and clean as needed. These icons are in there for anything that would be an event in there, whether it be a fusion splice, mechanical connector, macro bends, etc., which makes it very easy for somebody to pick up and get right to validating or troubleshooting and fixing the issue, rather than spending time interpreting what the issue may be from a traditional OTDR. Now, if we were to look at the Autotest procedure versus iOLM, this is really how iOLM actually does this. I spent a lot of time talking about pulse width, and this is where I'm going to show you the difference between iOLM and just an Autotest procedure, because both of them wind up being activated just by hitting the start button. So the Autotest finds the length of the span, which iOLM does as well. It then determines the best single pulse width based on the length of the span, and then it launches the trace at that single pulse width, which we said before is a compromise. Whereas iOLM automatically launches multiple pulse widths, short, medium, and long, based on the specific length of that span. And then, the Autotest, it'll provide that single trace result to be analyzed. Whereas what iOLM will do, which is based on the consolidation of each one of those multi-pulse width settings and traces shot, consolidates and integrates each of those results into a single result with a definitive pass-fail result. Autotest has an event table that needs to be analyzed, and what we have is the complete span view with understandable, very easy to read icons for all the information that you need to have to troubleshoot or validate that trace. In addition, iOLM will go the extra step and provide suggestions to correct based on the red or the fail events in the span as well. Another way to look at this is considering that iOLM would be an iceberg. What you see from the linear icon-based view is really 10% of what's happening. Everything else is behind the scenes, which is exclusive to EXFO. And it's basically the multi-pulse width algorithms that are patented by EXFO that allow us to make that machine that much more efficient and allows optimal results, basically with no OTDR knowledge, to anybody that is able to pick up, connect that machine to a span, and press the start button. So if you consider a link characterization with traditional OTDR versus iOLM, iOLM can perform a complete characterization up to 85% faster than either Autotest or advanced in traditional OTDR, which is significant. And from our aspect, when we present and show and interact with techs that are using it for the first time, we routinely go head-to-head with the company's least experienced tech, giving that least experienced tech an iOLM unit to use against their most experienced tech using their traditional OTDR. And typically we see iOLM winning on speed and accuracy every time. So there is that much of a significant advantage to iOLM, which is one of the reasons why we're presenting this to you here today. Lastly, with iOLM, although we have multiple traces that come out of one shot from behind the scenes, for one fiber, all we're going to be producing is one clean report with all the information in there, all of it interpolated into each one of those individual results. iOLM as a whole is available on each and every EXFO OTDR that we manufacture. And from a cost perspective, iOLM is actually included into the price of an OTDR. You, as a purchaser, would have the choice of either traditional OTDR software or iOLM, which is included at no charge. Now, occasionally we have techs that have, or companies that have, a wide variety of techs, both in age and experience. And there are some that feel adamant that they want to have both the OTDR and the iOLM, which we can do. However, there is an upcharge for that, right around the range of $2,000 additional. But any way you go, it is certainly one of the most innovative and most efficient and repeatable softwares out there for OTDR. Okay, what I'd like to do is shift the gears here a little bit to a new introduction from EXFO called our Optical Explorer. And it is a pretty good segue because we've been talking about OTDRs and trying to make them as efficient for you as possible. But if you're familiar with OTDR costs and capabilities, typical OTDR can run anywhere in the range from $5,000, $6,000, $7,000, upwards of $20,000, $25,000, even $30,000, depending on the wavelengths and number of wavelengths and capabilities and options that you get with them. And what we want to do is introduce this new class of product that we call an Optical Fiber Multimeter. So from a cost perspective, as well as complexity, these are challenges that face anybody who is going to be a potential OTDR user every day, meaning, one, they're going to be expensive, and number two, the complexity, the amount of things that an OTDR can do may be far more than what you need that OTDR to do. And you pay for everything you get with them, but you may not end up using them. Again, one of the things that we see more and more is that there is a need for a tool that allows the troubleshooting, verification, and validation from a more rudimentary perspective rather than the complicated perspective of an OTDR. So just to show you a quick chart that bases the cost of testing versus the capabilities of test equipment. If you look down in the lower left-hand corner, okay, we can do no testing, which doesn't cost us any money, which really doesn't give us much in the measurement capabilities end of things. If we combine both VFLs, which are visual fault locators, and fault locators, as well as light sources and power meters, I'm going to call those the first line of troubleshooting defense for any tech that is out there working on fiber spans and networks. These tools basically allow you, with a light source and power meter, for instance, a light source will provide light down a span that a power meter can pick up and interpret the value of the light coming down. And very simply, from that value, it can determine, or you can determine, if there is or is not an issue. If the power on the meter from the light source is less than you expect or more than you expect, or if you're expecting power and there is none, or vice versa, that's pretty much the extent of what a light source and power meter can do. Now, based on that, the cost is going to be far less than an OTDR, but the capabilities are going to be less also. And then if you go at the far end with an OTDR, they're going to be expensive. And again, the capabilities are going to be there for more than just troubleshooting or validating. You can do bidirectional testing. You can do full fiber characterization. All these things are in there that really make it a very complete but very complex piece of test gear. And what EXFO has done is centered in on this class of both the dollar-wise of what it costs, as well as the amount of capability. So you can look at this as one of two ways. You can look at it as a power meter and light source on steroids, or a scaled back OTDR, because The OTDR is the second line of troubleshooting defense, meaning a power meter and light source will show you or tell you that there is a problem, whereas an OTDR is needed to tell you what the problem is and where it is. And the Optical Fiber Multimeter is going to be able to give you that basic premise of an OTDR. And we're calling it a multimeter because it's very similar to what an electrician carries. He carries a digital multimeter that he can use for go, no go testing, some interpretive analysis, and it's going to measure multiple things, ohms and volts and amps. With our fiber multimeter, it's going to be very similar in practice. It's going to be for go, no go testing. It's going to give you the length of spans. It's going to give you the distance to and identification of faults, which is the big deal as to why most people use OTDRs. It's going to give you loss, insertion loss. It's going to give you the ability to generate tones for fault location and fiber identifiers as well, all in one handheld tool. So again, we're simplifying the fiber testing, and we'll show you that with hopefully some hands-on. We'll have some time here for a visual, as well as reducing not only the cost, but the complexity of fiber testing. Now, very quickly, we're going to go over 5 different types of tests that are on this unit. So the first one that we're going to look at is the flash advisor. It's going to be a very fast, simple 3-second test. It's going to give you length, insertion loss, and optical return loss. In addition, it's going to give you a 5-star rating, just like if you're purchasing or planning to book at a hotel. It will give you the quality or the caliber of that entire span and events that are on it. If you get a 4 or 5-star rating, you may say, oh, I'm good to go. If you get a 2 or a 2.5-star rating, then you're going to have to find out where those issues are. In which case, you would then go to our 20-second test, which is the Fault Explorer. It'll give you the same info that the Flash Advisor gives you, but now, which is unique to EXFO and this product, is that it will also give you bad events that are on that span. So when you think of using an OTDR and everything you have to do, you're trying to find where an issue is. This Fault Explorer mode will give you that information. It also will have the advisor, but it will also give you pass-fail. And obviously, if there are faults in there, it's going to be a fail. Lastly is the Link Mapper that will give you not only everything that the Fault Explorer gives you, but it's going to be very similar to a full OTDR iOLM trace in that it's going to give you both good and bad events. So from a finalizing the work perspective, from a validation perspective, from a trust but verify perspective, or just an archiving perspective, the Link Mapper can be very useful to be able to have that information documented and archived at the end of a job. Lastly, down below here, it also comes with a light source and power meter or power checker so that you can utilize it for the first line of troubleshooting. And also, it's going to have modulated tones that you can produce in there, such as a 2K tone, to use with a fiber identifier to be able to determine, specific spans that you're on, or doing some go-no testing from a fiber tracing perspective as well. So let's delve in just a little bit and take a look at what these screenshots are going to look like. So the first one up that we have in yellow is going to be the Flash Advisor, which is highlighting this button here, which is the Flash Advisor, and then hitting the Start button. And 3 to 5 seconds later, you're going to have the length, the loss, the optical return loss, as well as a 5-star rating. So very quickly, you can determine, is that span what you expect it to be? Or is there an issue on it? Now, if you don't get 5 stars, if you get high loss, if you get other issues, if the length isn't anywhere near what you were expecting, then you're going to run a Fault Explorer. So if we move that over to the Fault Explorer, that's where you're going to run a 15 to 20 second test, which is going to really run basically an OTDR trace and come back with only the bad events. Now here we see it fails. It gives you a length, also the loss, and the optical return loss. In addition, you now have individual icons, just like you have on iOLM. If you click on this one, and we'll show this in the live demo, if you click on this one, it then brings up the reflectance and the loss for that particular event. so that you understand exactly where the issues may be and what is exceeding the tolerances or the thresholds. And lastly, we have the link mapper, which gives you, let's say you had an issue that you repaired and you want to confirm everything's good and that that particular event or connector is finalized and finished. Well, now you go back and you run the link mapper. This is going to be a 25 to 30 second test. And as you can see here, you would get a pass, you'd get the length and the loss and the ORL, and then you would get all the events as well. And if it passes, then every single event here of the 5 events are going to show as good with a green check. So all 3 of those all in one handheld test. What else is nice is that to run these tests, as well as either the power meter or the light source, you never have to remove the connector from the single port that's on the unit. It just switches automatically internally, which is a nice feature as well. So from a reporting capability, the OX-1 has the ability to Bluetooth right into your smartphone. So as we see here, we've got a particular test that can be Bluetooth, and once you open up the app that we have for this, which is called TestFlow, you then have the ability to look at both current tests and older tests, and you can then dial into each one of those. And once you dial into a specific test, you then have the ability to have you have an option there to then share that any way that you'd like in a PDF report format. So you basically click on PDF reports and fill it in, whether it is being shared, emailed, text messaged, Bluetooth, whatever it may be. It then has the ability to then be transferred right from your smartphone to wherever you need it to go. Now, the looks of that OX-1 report are not going to be as detailed and as complete as a full OTDR trace report. However, it's going to have almost everything that you're going to need from a verification and validation perspective. As you can see here, it's got the actual ID information and location, whether it be location A and location B. You can get as detailed as you'd like with the information you provided here. It's also going to have the test parameters, what wavelengths you shot at, if there was a launch cord, etc. And then obviously it's going to have the test results, not only for the overall link or the span, but also for each individual element as well. So if you're a contractor and you're doing work and need to confirm to your customer that what you did was repaired and repaired correctly, you now have a report that you can provide to them. So all in all, we've tried to package as much as we possibly can that we felt was needed from a troubleshooting and validation perspective for frontline techs, a handheld, cost-effective fiber multimeter. Now, one of the other things that makes this very unique and typically innovative, which is what you would expect from EXFO, is we have introduced on this unit what we call a click-out optical connector. And typically when you have a traditional OTDR that is able to shoot out and mark events and do characterization of fiber and all of that, that front-end connector of an OTDR typically has to be within calibration, which traditionally is within a 12-month period of time. And current calibration date or cal spec typically needs to be done for any kind of spec work or characterization work. What we've done is eliminated that by putting a click-out connector on the top of this, and integrated into the test unit itself is also a self-test to tell you if this connector in there meets specs or not. And if it doesn't, if it is either worn out from just the end of its useful life, which is in the range of any typical connector of 700 to 1,000 insertions, if there's been dirt left on it and it's been ground in, if a blue UPC has been connected to a green APC and it's chipped an edge, whatever the reason may be, if it is no longer good or has been degraded, you can just click it out and replace it for a minimal cost. A typical calibration is in the range of $600 to $700 and 2 weeks out of the field downtime. These click-out connectors are in the range of $350 to $380. You can carry a spare with you so that you are never down in the field as well. Now, this is an important slide with information to really determine the difference between the OX-1 and Optical Fiber Multimeter and a true full-blown OTDR. So here's what an Optical Explorer will not do that an OTDR does. So first and foremost, the OX-1 will not provide a traditional Bellcore.SOR trace. If that is what your requirements or specs are to turn in for payment or verification or finalization of the job, then this is not for you. That would need to be through a traditional OTDR. The OX-1 also does not provide the full characterization and is not able to correlate and compile bidirectional OTDR testing results. It also does not give you the ability to adjust or massage the pulse width, the range, the averaging adjustments. Also, it is not capable of testing through splitters in a PON environment. Now, it can test up to splitters, but one of the things we had to take into account to reduce not only the size, the complexity, but also the cost was to reduce the power of the laser that's in here. By reducing it, it's not going to be capable of shooting through splitters because they are significant drains on dB or power from a laser. So in essence, this is going to be for that frontline last mile technician. It can test spans up to but no longer than 25 kilometers. And as we say, it's not going to be able to test through splitters. But for any of those quick checks, moves, adds, changes, break fixes, any of those, troubleshooting, investigation, this is absolutely going to be a great tool to fill that bill. Now, there are two different models here, and what I've explained is all the features of the Pro model. Now, what it has is the light source and the power checker, the 5-star rating, and then the 3 tests that we discussed at the core of this, the Flash Advisor, Fault Explorer, Link Mapper, as well as the replaceable click-out connector. There is a basic version that does not have the Link Mapper, which is the full event mapping, or the click-out connector. Now, if you're somebody that may use this and pull it out once or twice a year and you just need something for a trust but verify, the basic may be the way to go. It is an option, but everything that I've seen and my recommendations at this point is that the Pro is the way to go. The wavelengths that this is available in are, we have 2 currently. It's 1310, 1550 for the installation end, and then we do have a maintenance version, which is a filtered 1650 live filtered port. On the Pro version, we also have both of those combined into 1310, 1550, combined with the filtered 1650 live. Now, just a quick shot of what our pricing is from an EXFO list price perspective. You can see here that from a basic model for 1310, 1550 dark, this is as low as $26.90 list price. Now, that same version in the Pro, which is the one that is my personal recommendation, is $32.90. So it's a $500, I think, jump in price, but the additional features are well worth it. We also have 1650 live in the Pro, and then we have the combined for everything at just under $6K list price. Now, the last thing I'm going to do before we get to questions is I am going to try to escape out of here and show us just a very quick demonstration. It's only going to take a couple of minutes just to run through this real quick. So let me escape here. Let me do this. Show application. It's that delay. It keeps, there we go. And I want to go to Team Viewer. There we go. So I have right over here an EXFO OX-1. And from here, we have the ability to select Fiber Explorer, power checker, light source measurement settings. We're just going to go right to the Fiber Explorer. And what we have here is a test that was just done recently. Forgive the auto focusing. I don't know that I can do much with that. What I'm going to do is I have a different setup to my left here, which is just a series of launch cables connected together. And they're my trade show version, so they aren't the best in the world. I'm going to click on the Flash Advisor, which is the 3 to 5 second test. I'm going to click the Start button. And there we have a result. So what I have showing is a 2 out of 5 star rating on a 320 meter span with 4.4 dB of loss and an ORL of 44.3. So at 2 stars, I don't need a lot of experience to realize I've probably got an issue there. So let's see where those issues may be. And all I'm going to do at this point is click on the Fault Explorer and hit the Start button. Now this is in a 15 to 20 second range. And you can see there's a dial going around, and once that's finished, the test will be done. There we go. So now what we have that we didn't have on the Flash Advisor is down in this lower portion, we have individual icons. And I'm just going to show you the one here. It's got a red X on it, and in my view here, it's red. So if I click on that, it's then going to bring up all the individual characteristics for that. So obviously I've got 1310, I've got acceptable, 1550, it's in red. So my loss there, 3.8, is really high for a connector. The reflectance looks okay. So in that area, if you notice at the top, it says group. And it's actually saying that there's multiple events there. And if I go down further to look at sub-elements, it's showing the connector as well as a macro band. So when I mentioned this was my trade show launch bag, inside of my launch bag where I have a cable tie, keeping everything together, it's actually cinched very, very tight, and it's right next to where that connector comes out of. So it is showing what we have available. Now, the last thing I want to show you is that if I go back to the original test, OLX54, I am updating my Optical Xplorer on my phone, and hopefully you can see this. So I've actually opened the app test flow, and what I have here is OLX54, and if I click on that, I then have the information that okay, I just noticed this. Sorry, I didn't plan in advance, but this is interesting. On my OX-1, I've got 319 meters, whereas on my phone, I have the settings set for kilofeet. So it's 1.0 kilofeet, but the loss and the ORL are all the same. And if I wanted to create a report and send it, I then have the PDF. Just very simply, I can do that and create the report. And from there, I then have the ability to send it. So there it is. I can click down below, and whatever I need to and however I want to see, whether it's airdrop messages, etc., I have the ability to then send that. So that's going to conclude a basic test and run through of the Optical Explorer. And now what I do is, Dominic, I'd like to turn it over to you and just leave it as questions, if there are any. Let me see if I can see change presenter. I think that's my job. So Dominic, you're going to have to let me know if you have control.
Yep, I believe I do, Jim. I'm just trying to make sure I show the appropriate screen here with our final slide.
Okay.
There we go. Cool. Well, Jim, I really appreciate your time. And for anyone that's joining us, I know we have a couple attendees. If you guys do have any questions, please feel free to submit your questions in the chat icon on the right of your screen to be able to ask Jim some questions. I also want to let everyone know that the webinar will be posted on T Equipment, and we'll have send out follow-up email with all the information and documents to access in the future. While we wait for a few questions, I do have a couple for Jim. Jim, can you tell us, does the iOLM software replace the traditional OTDR software?
Good question. It actually has the ability to replace the traditional OTDR software. When I talk about traditional OTDR versus iOLM, it's like the second generation. So in our eyes at EXFO, yes, it absolutely does. But what we do is we provide the ability to have any OTDR be configured with either traditional OTDR software or iOLM software, or in some cases where it's a benefit, both sets of software can be provided on any of our OTDRs.
Great, thank you. So just to clarify, you can get both the iOLM software and the OTDR software.
Yes, small up fee, but yes, there is the ability to do that.
Awesome, great. I think we have another question here. Can you tell us how long does it take the iOLM software to run a complete trace?
That's going to depend, just like the OX-1, it's going to depend on the length of the span. The longer the span, because if we go anywhere from, we've got the ability to shoot spans as short as a couple of 100 feet, upwards of 50, 60, 70, 80 miles. So if you're shooting, 60, 70 miles, the length of time for that to characterize everything and shoot the multiple pulse widths is probably going to be in the range of 20 to 30 seconds, maybe 35 seconds for those real long spans. Typical shorter ones, let's say less than a mile or a couple of miles, it's going to be probably in the 20-second range, 20 to 25 seconds. So nothing really out of the ordinary. I know on traditional OTDR, you can dial down the averaging time to a 5-second test. There is an option within iOLM to be able to do what we call short opti mode for short spans as well.
Okay, great. Looks like I received a question here from one of our attendees. On the Optical Explorer, how long should a click-out connector last?
Good question. If it's taken care of properly, and if a launch bag is used where the launch bag is not inserted and reinserted every single day, then a click-out connector can last for a few years, if not longer. Now, if you want to know from just insertion and reinsertion, the typical traditional industry standards for a connector are in the range of, you can pick a number anywhere between 700 to 1,000 insertions or reinsertions before the degradation of the end of that connector is at a point where it will not meet calibration specs.
Okay, great. I don't see any questions coming through the chat at the moment, so I believe that will conclude our webinar presentation with Jim Miller from EXFO. Jim, if there's anything else that you'd like to add, please feel free.
I think I'm good to go from this end. I want to thank you for the time, Dominic and T Equipment. Appreciate the opportunity.
No problem. We thank you, Jim. Just to reiterate, I just want to thank everyone again on behalf of T Equipment and EXFO, and we'll be posting the webinar on our website, and there's some links and information on the slide I'm showing right now, and you also receive a follow-up email in the next day or so. So thank you, everyone, and please stay safe.